Next we have here is missing data. So when dealing with missing data, data scientists can use two primary methods to solve the error, either impute or removal of data. So basically, data can go missing due to incomplete data entry, equipment malfunction, losses of file, many other reasons. In any data set there is usually some missing data, either it doesn't got collected, or you know human, basically human error. So sometime we forgot to type complete address, last name, pin code, etc., this type of information. So before deciding which approach to employ, data scientists must need to understand why the data is missing. Okay, so 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 the imputation method develop reasonable guesses for missing data. So it is like uh, most useful when the percentage of missing data is low. But if the portion of missing data is too high, the result will lack in natural variation that could result in effective model. Okay, so the other option is removal of data. So when dealing with data that is missing at random, related data can be deleted to reduce bias. So removing data may not be the best option if there is not enough observation to result in the reliable analysis. So for situation like this, we basically consider three main you know uh, approaches to basically deal with it. One is missing at random, another one is missing completely at random, and third one is missing not at random. Okay, so missing at random means that the data is missing related to the observed data. So so that means the data is not missing across all observation, but only within subsample of the data, which means the missing data can be predicted based on complete observed data that we have. Now the second is missing completely at random. Okay, so the data is missing across all the observation regardless of expected value or other variable. Okay, so it is typically safe to remove missing completely at random data because the result will be unbiased. Okay, the test may not be powerful, but the result will be reliable. Okay, and that is what we use missing completely at random when we have such situation. Now we have last one, that is missing not at random. So it basically applies when missing data has a structure to it. In other word, um, the data is missing for particular region. So suppose you have done a survey, some of the survey we basically do like to collect some of the data, like how people spend their time, how, what is the average number of ratio people are earning. So these type of survey we basically do, and obviously some people wants to be anonymous, and obviously these results are anonymous, but also we don't fill our everything like address, phone number, these type of information are relatively missing all the way. And so basically the data scientist must model the missing data to develop unbiased estimate. So simply removing the observation with missing data result in model with bias, and that is what this missing not at randoms comes in. So so you basically the data cannot be determined by the observed data because the missing information is unknown, because it comes with person to person with different thinking, different you know d- uh, I mean demographics, age group, another information, and for that reason you will be removing such data. But you will also try some other way to feed data, because you want to develop a model with unbiased estimate. So removing observation with missing data could result in model with bias. So anyhow you will be doing some analysis and feeding feeding the data with the method that is available, and you will be doing the modeling part. Okay, so that's all for we have in missing data.